This video is for class 9 physics, and we are doing position of image, and we shall also do lateral inversion. So the position of the image I is as far behind the mirror as the object O is in front of it. That means if you place an object 2 meter in front of a mirror, the image will be also formed 2 meter inside the mirror or behind the surface of the mirror. That is, the perpendicular distance of image from the mirror is equal to the perpendicular distance of the object from the mirror. So now if you look at this particular figure, right, you can see this object O, if it is placed 2 meter away from the mirror here, the image I will also be formed 2 meter behind the mirror. This has a geometrical proof which we are skipping because it is not in our syllabus, right. Thus we can say the image is situated on the normal drawn from the object on the mirror, and it is as far behind the mirror as the object in front of it. So here they are talking about this normal here, okay, here they are talking about this particular normal here, okay. They are telling that object and the image fall on the same line here, this line, okay. So I hope this is clear. Now we can go to the next topic, that is lateral inversion. We are going to the topic lateral inversion. So in our daily experience, while looking in the mirror, we notice that a ring on the finger on your left hand appears to be on the finger on the right hand of your image, as shown in this figure 7.9, this one here, right. If you raise the right hand, the image in the mirror will raise its left hand, right. So this phenomena is called actually lateral inversion. So similarly, the pocket on the left appears to be on the right in the image. This interchange of the left and right sides is called lateral inversion. Thus the interchange of the left and right sides in the image of the object in a plane mirror is called the lateral inversion. This is our common experience, right. So this figure shows here, again we need to learn to draw this figure also. This figure shows a lateral inversion of the letter P with the help of a plane mirror. So to draw this particular diagram, okay, let us go to one image, right, one figure. So we have come to this particular figure, okay, which we had learned in the previous video. In the same figure, if you just add this particular P here and this P here, thus our image is over, thus our diagram is over. You just need to put those P here, right, the front part of the P. Or if you want to draw any other alphabets, okay, we can put any alphabet, like we can put A, we can put A here, right, or we may put any other alphabets like B here, right, B, R, okay. So many things can be adjusted in between these 2 points. So I hope you have understood, right, this particular diagram of the lateral inversion. Then we can go to the next point of lateral inversion. So coming back to our book, point number 2, the lateral inversion of letters such as A, which we had just seen, H, I, M, O, T, U, V, W, X and Y is not noticeable because their image remains unchanged. Why? Because each of these letters has a symmetry about a vertical line passing through the midpoint of the letter. For example, if I want to draw A, okay, A, right. So if I consider this vertical line, it has symmetry. That means this portion and this portion of A is same. Whereas if I want to write B, if I draw a vertical symmetry, right, symmetrical line here, this will be broken into this particular part. Hence this becomes like 13, right. whereas this does not become. Okay, when I break the part it will be like this, so which looks similar, but here they are not looking similar, sorry. So because of this region their mirror images are unnoticeable. Okay, the next thing, it is because of the lateral inversion that it becomes difficult to read the text on a page from its image formed by the plane mirror, but one can easily read the text written laterally inverted letters formed by seeing its image in the plane mirror. It is why the letters on the front of the ambulance are written laterally inverted like ambulance. So the driver of the vehicle moving ahead of the ambulance reads the word laterally inverted, that is in a proper way ambulance, in his rear view mirror and gives sight to pass the ambulance first. It is done same thing for the fire brigade vehicles also. Coming to the last point of this particular section, that is characteristics of the image formed by a plane mirror. Characteristics of the image formed by a plane mirror. There are 5 of them, but here it is just listed 4. The image formed by a plane mirror has the following characteristics. The image is always upright, it is always virtual, it is of the same size as that of the object. That means if you are of 4 feet high, suppose your height is 4 feet, then the image will be also 4 feet, right. Then it should be laterally inverted, we just discussed that. Okay, and the 5th one which I was talking about is the location of the image is given by the fact that the image is situated at the same perpendicular distance behind the mirror as the object is in front of it. That's what we had started this video with, right. So note, if the object is shifted by a distance d towards the mirror, the image will also be shifted by the same distance d towards the mirror, that is from the behind the mirror. Okay, that is the separation between the object and the image will be decreased by 2d. Similarly, if the object moves with the speed v towards or away from the mirror, the image to him will appear to move with the same with the speed of 2v towards the away, sorry, not the same, this with the speed of 2v towards or away from the object, right. So because one speed is for the person himself or herself and the other speed is for the image, therefore 2, we are having 2 here. For example, a boy standing at a distance of 5 meter away from a plane mirror as shown in this figure, okay, at A, right, at this position A, sorry, at this position A, finds his image at a distance 10 meter from him at A dash, that is 5 meter plus 5 meter, which is 10 meter. Now if he moves to the position B, suppose he goes back, okay, now he is at 7 meter away from the mirror because he moved 2 meter right back. So still further away from the mirror, his distance from the mirror will become 7 meter. Then to him the image B dash will appear to be at a distance of 14 meter because this 7 plus 7 shall give me 14. So I hope you have understood this particular characteristics of image formed by a plane mirror also. This much for this video. Thank you so much.